Mixture problems can be solved using a system of equations. We just need to make sure we understand how to set up our variables and our equation. So with any word problem, we want to definitely figure out what are we trying to find. Okay, so we look at that last sentence. So we want to know how much of each solution is used. And it looks like here we have a 5.3 molar solution. So molar solution means that that's the concentration and of calcium hypochlorite, and it's mixed with 3.2 molar solution of hypochlorite. So these are concentrations. These numbers represent the concentration, and it makes up 900 milliliters of 3.9 molar hypochlorite. So these are concentrations. So basically it's going to look like this. We have 900 milliliters of solution, and it's made from 3.2 molar and 5.3 molar solution, and we end up with 3.9, so somewhere around here. Okay, so 3.9 molar. Okay, so this is like these are concentrations, so as we mix them, the concentrations will change. When we have a weak concentration and a strong concentration, we kind of end up with a middle concentration. So how much of each solution is used? So we're going to make our let statement. Let X equal the volume of 5.3 molar solution. And then we're going to let Y equal the volume of the 3.9 molar solution. And we're going to then come up with our system. So we need to have two relationships. So one relationship is going to be based on the volume. Okay, so we can say here that we're going to come up with 900 milliliters of that solution. So we can say that X plus Y, the volume of the 5.3 plus the volume of the 3.9 molar solution, is equal to, and I'm going to convert this to liters because I'll explain why in a second. So it's going to be equal to 0.9 liters. Now the reason why I turn this to liters, because the molar solution is based on, the units are moles per liter. Okay, so if I multiply this by liters, I get the number of moles, or the number of the actual amount of this calcium hypochlorite. So that's what I'm going to do. I'm going to make my second equation based on the total amount of the hypochlorite that we have. Okay, so if we multiply the moles per liter, or the concentration times the amount we have, we get the total amount of whatever the substance is. In this case, it happens to be hypochlorite. So we're going to take the 5.3 moles and we're going to multiply it by volume X. So this represents the amount of hypochlorite. So this is amount of hypochlorite. Okay, and this is in green here, this is the volume. And these concentration problems essentially work like this. You have your volume, you have the volume times the concentration gives you the amount. Okay, and we can set this up slightly differently, but it works easiest if we multiply these and we generate the total amount and make an equation for the amount of the substance that's in question here. So I'm going to take the volume of the 3.9 molar hypochlorite, and I'm going to multiply that by the concentration of hypochlorite. So 3.9 molar times the volume Y. And that's going to give us the total amount, it's going to be 3.2. Okay, so that's 3.9 is what we end up with. So this is, let's just change that, the volume of 3.2 molar hypochlorite. And this is going to equal the total amount of hypochlorite, which we calculate by the volume of the 3.9 hypochlorite times the concentration of the 3.9 molar hypochlorite. Okay, so we know the total volume, and we know the end concentration. So that's the total amount that we're going to end up with. And this is how we get there. So this is how we establish our system. So we can take our equation here, solve for x, and then I'm going to substitute for x in the equation 2. So I end up with 5.3 times x plus 3.2y is equal to 0.9 times 3.9. Let's use my calculator for this. 0.9 times 3.9 gives me 3.51 moles of hypochlorite. Okay, and then I'm going to replace like for like. The x gets replaced with an equivalent expression of 0.9 minus y. So multiplying this out and solving for y, we get 5.3 times 0.9. That gives me 4.77 minus 5.3y plus 3.2y is equal to 3.51 moles in total. So subtracting these, we end up with negative 2.1y, and on this side we get negative 1.26. Okay, that looks right. Okay, and then divide to solve for the volume of y. We end up with 0.6 liters of the 3.2 molar solution. Okay, so if 0.6 liters is for the 3.2 liter solution, then we're going to have 300 milliliters or 0.3 liters of the stronger solution. So the volume of the 5.3 molar solution is going to be 0.3 liters. Okay, so there's our solution to this.